So now we've got three terms, first, second, third, and we can see this is factored, this is factored. We need to factor this in order to get the LCD. So let's rewrite all of this. We'll have 1 over the x plus 1 plus x over the x minus 6 minus the 5x minus 2 over, we'll factor, x and x. Now, here's how these problems are going to go. Here's one part of that's one factor of the LCD. Here's another. We're going to have at most three factors. So I'm looking at x plus 1, x minus 6. I'm looking at a 1 and a 6. What do I think I should do with this 6? 3 and 2 or 1 and 6? Let's go with the 1 and the 6. I'm going to go with a 1 and a 6. The 6 is negative, so they'll opposite signs. How about plus 1 minus 6? And sure enough, negative 6x plus x is negative 5x. So we got it factored. We can write the LCD. The LCD here is the x plus 1 and the x minus 6. Does that make sense? The x plus 1 appears, so we need that. The x minus 6 appears, so we need that. Now they appear over here again, but they're still just to the first power. So we just need one of them here, one of them here. Let's draw a big fraction bar and write LCD. And now let's go back to the originals and make any adjustments to the numerators, right? If we adjust the denominator, we have to adjust the numerator accordingly. So let's make adjustments. What do we do with this 1, if anything? So we're going to have a 1. Now, compare the original denominator to the new one. It's right below it. What do you see? What's missing? Whatever's missing, that's going to be our adjustment factor. So the x plus 1 appears. What's missing is the x minus 6. So you can see, right, you can see it right here. We're multiplying the denominator by x minus 6. So we have to multiply the numerator by x minus 6. So we'll have 1 times x minus 6. And then plus. Now, what about this x? What about that x? Any adjustment necessary? Well, let's compare the original denominator to the new one. There's the x minus 6. You can see what's missing, the x plus 1. So you can see that the original denominator is being multiplied by x plus 1. So if we multiply the bottom by x plus 1, keep it balanced, multiply the top by x plus 1. And then, a long fraction bar here, minus. Now, what about this 5x minus 2? Any adjustment necessary? So compare the original denominator to the new one. No change, right? X plus 1, x minus 6, x plus 1, x minus 6. No change to the bottom, no change to the top. So we're just going to subtract. Now be careful. There's more than one term, so we need to capture all of it in that subtraction. So minus, right, there's the minus, all of this, all of it. There's the parentheses. All right, let's multiply through. We'll get x minus 6 plus x squared plus x. Then take that minus sign through, minus 5x plus 2 all over. Now, because we can still do quite a bit, I'm going to write LCD. Let me just be sure I've got that right now. X minus 6. X minus 6 plus, okay, x squared plus x. And then take the minus sign through. Minus 5x plus 2. Looks like we got it all. Let's simplify. So we will have x squared, and now what else do we have here? I've got an x, another x, so 2 x's minus 5x. X plus x is 2x minus 5x minus 3x, and then minus 6 plus 2. Minus 6 plus 2 is a minus 4 over, now I'm going to again write LCD because we can factor that top. Let's do that way up here on the right. So let's factor that top. Top will factor as, we get x and x. I think it's going to be a minus 4 and a plus 1. Just check it. X minus 4x. Yeah, that's going to work. Minus 3x over, now because I can't do anything else, I'm going to write the actual LCD. And I've got the LCD right here. So just write it right here. So it's going to be x plus 1, x minus 6. And now we see that x plus 1 on the bottom and the top. We can cancel those and write our final solution like this. Solution, our simplified form is x minus 4 over x minus 6. And we can do that, right, as long as x is not equal to, bring it back a step, not equal to what? Negative 1 and 6. So again, we're replacing this set of computing instructions with this much more compact, more efficient set. And we can do that as long as we don't use these two numbers. Let's get the LCD here. The LCD is x plus 2. So a big fraction bar, LCD on the bottom. Now, here's the top, 3x plus 5. So 3x plus 5, and then we ask any adjustment necessary. So compare the original denominator to the new one. No change, right? The original is the same as the new, so no change on the bottom, no change on the top, no adjustment necessary here. Then we're going to have a plus. Now, what about this 2x? Any adjustment necessary? Any adjustment to this 2x? Well, compare the original denominator, which is really, there's a 1 here, right? Isn't there really just a 1 there? So the original denominator is 1, but now it's x plus 2. So we multiplied the bottom by x plus 2, so multiply the top by x plus 2. So we're going to have a 2x, adjust it, multiply it by x plus 2. There we go. Let's expand. 3x plus 5 plus, and then 2x times x is 2x squared. And then 2x times 2 is plus 4x, all over LCD. Simplify. This will give us 2x squared, and then, right there's the 2x squared, and then 3x and 4x is a 7x. And then we've still got that plus 5 here, over the LCD. And number 30, we've got a fraction and a whole part. Let's get the LCD. So the LCD is x plus 2. Right, that's the only denominator. There is actually a denominator here, but it's just a 1, right? 2 over 1 is 2. And now, here's our big fraction bar. And write LCD on the bottom. Now, let's look at the tops and make any adjustments that we have to. 3x plus 5. So here's the original top. Now, any adjustment necessary to this? Well, compare the original denominator to the new one. No change. So no change on the bottom, no change on the top. So no adjustment necessary here. But then we do have a plus 2. Now, look at this denominator. It's really a 1. You have to see through it. There's a 1. We're changing it to x plus 2. So if we multiply x plus 2 times 1, we have to multiply the top by x plus 2. So this is a 1. You can see the missing factor is x plus 2. So multiply the top by x plus 2. Let's multiply out 3x plus 5 plus, now distribute here, right? We'll get 2x plus 4 all over. I can still do something, so I'm going to write LCD. And then 3 x's and 2 x's. We got 5 x's. And then 5 and 4 is a 9. Now, can't do anything else, so I think we're done here. So this is going to be our LCD, which is x plus 2, so it looks like we've got it here. So the original expression right here is going to be reduced by this new expression right here.